Hi guys, this is John here. Continuing our course on artificial intelligence, I will now start with session number 4, which is focusing on how do you make a machine identify objects. So now we are entering our phase of machine learning. Now, in session number 2 and session number 3, we were focusing on how we make a human learn and how do we gauge whether a human has learnt accurately or not. So we had a situation where we would make a human classify and we would make a human predict, and we were able to judge whether the classification or prediction was accurate or not. So we had covered this in session 2 and session 3. Now session 4 onwards, our focus will now be on machine learning, as this course is called artificial intelligence. So we'll be focusing on machine learning, and session 4 starts off with how do we make a machine identify objects. So if you remember, we use the term classification for identification. So in this session, we will see how do we make a machine perform or implement classification. So let's go ahead and understand that. We will also have a lab lecture as part of this session. So from now onwards, our practicals will begin, and this should be more fun because now you will be doing hands-on AI experiments. So looking forward to it. Let's make it more fun here. So now, first things first, how do we make a machine learn? First and most important point is for you to understand the problem statement, which is what do you want your machine to learn? That's the most important thing. If you cannot understand the problem statement, there is no point in implementing machine learning. So once you understand the problem statement, then to teach your machine or to train your machine, you need to select the data, and then you need to split the data between training and testing. In step number 3, you will be keeping aside this testing data. In step number 4, you will make the machine learn. In step number 5, you will be testing the machine's accuracy using the data that you had kept aside in step number 3. And only if you are happy with all these 5 steps, then you can decide my machine is ready to go into the real world. Now, let me ask you a question. When I was describing step 1, step 2, step 3, step 4, step 5, are you able to remember some concepts from session 2 and session 3? Are you able to remember something there? If you remember, our human was also doing something similar, where in step 1, the problem statement was the competition, if you remember. So Jimmy had to prepare for the competition. Our step 2, the teacher was preparing the information or the practice problems for Jimmy. In this case, for machine, it was the data. In step 3, the teacher had used some questions to test Jimmy. Step 4, the teacher was teaching Jimmy. Here we are making the machine learn. And in step 5, we were testing Jimmy. If you remember, Sarah was testing Jimmy and preparing the confusion matrix, or she was calculating the error. In session 2, we looked at the confusion matrix. In session 3, we looked at error and the concept of average error, if you remember. So basically, you can compare how a human learns with how a machine learns, and the steps are fairly similar. First, you have to understand the problem statement. Then you have to select the right kind of practice problems for your machine. I am using the same terms that we are familiar with session 2 and session 3. Now that we've kept some problem statements aside for the machine to test, we go ahead and train the machine using a right learning method. So now I'm using a term called learning method. Now, do you remember in session 2 and session 3, who was our learning method? That person was our teacher. So we had teacher 1, teacher 2, teacher 3. So similarly, the machine will also have a learning method. And last, when we are testing the machine for accuracy, for Jimmy, the testing was done by Sarah. Here we will use a software to test our machine. So basically what I'm trying to say is human learning and machine learning are fairly similar in terms of the method. I'm being very clear that human learning and machine learning are similar in terms of the method. Okay? So now that we have understood that machine learning follows a similar process like how a human learns, let us go ahead and see how we will follow these 5 steps. The first and most important step here is you need to understand the problem statement, which means that are you doing a classification or are you doing a regression? Now, regression means estimation or prediction. For a machine, the term used for estimation or prediction is called as regression. For humans, we can say estimation or prediction, but for machines, now we will use the term regression. And for identifying objects, we will use the term classification. So if you remember in session number 3, I had explained the difference between classification and estimation. I will describe it again. When you have a distinct number of outputs, for example, if you want the machine to identify based on the name of the person, whether it's a boy or a girl, then this problem is classification because you are classifying whether it's a boy or a girl. So as I said, if it's a distinct or a fixed number of outputs, again I will repeat, if it's a distinct or fixed number of outputs, then we call it a classification problem. Whereas if you have an infinite number of outputs, for example, if you're trying to predict the forecast or the weather, you can have an infinite number. Infinite means it is not fixed. It could have any number of values. And there, when your machine has to estimate or predict this output, then we call it a regression problem. So first things first, you have to decide whether your machine is performing a classification problem or a regression problem. This is very important for you to understand. Based on whether it's a classification or a regression problem, you will then decide the learning method, and I'll come to that. So step number 1 is decide whether you're going to do classification or you're going to do regression. Okay, that's step number 1. Step number 2 is you need to select the correct data for your machine. And I would say the correct data for your machine and the specific problem that you are addressing. And that tells us that first you need the right type of data. For example, if I'm trying to say based on the name, whether it's a boy or a girl, and now instead of giving the machine names of people, I'm suddenly giving the machine names of cities. Do you think the machine will learn properly? The answer is absolutely no. So, giving the right type of data is very important. And the type of data depends on the specific problem statement. Please understand this. So step 2, the first part is to understand that are we giving the right type of data, and the second important thing is, are we giving the right amount of data? Now the question is, what is the right amount? No one knows. So you have to keep trying with your machine until you get it right. I'm just taking a funny example here. It's like you coming and asking your father, Dad, how many problems do I have to solve to get full marks on my maths exam? Try that question with your dad, and he'll say, the more, the better. So the same concept is here, is what is the right amount of data? My answer would be the more, the better. Okay. So step number 2 is selecting the correct data for your machine. Step number 1, as I said, understanding whether it's a classification or a regression problem statement. Step number 2 is selecting the correct data for your machine, where we are looking at the right type of data and the right amount of data. Step number 3, it is very important that you keep some data aside for checking whether your machine has learned properly or not. So this is basically your testing data. If you remember, for Jimmy, there was some training data and there was some testing data. Similarly, for our machine, we have to split our data into 2 parts. One is the training data and one is the testing data. Let me explain to you again from a human perspective. Let us say you have a textbook, and the textbook has 100 mathematics problems. Now you need to decide, if you go ahead and read all 100 problems, will you have any problems for practicing? Answer is no. If you read 10 problems and you practice 90, do you think you will be able to prepare better? Answer is no. So you want to try at least 70 problems by reading them and practicing 30 problems on your own, so that you know that based on these 30 problems, what are your chances of getting a good score. Similarly, for your machine, you have to understand that we have to split the data. Some of the data is for making the machine learn, and some part of the data is to make sure that the machine has learned properly or not. And this split is very important. Now your next question to me would be, what should this split be? Well, my answer is try with your machine. There is no right answer here. You need to try with your machine. You have to try again and again until you get a higher accuracy. And in our practical sessions, we'll be looking at how to split the data between the training set and the testing set. Now, what we have looked at till here is, in step number 1, we identify our problem statement. In step number 2, we select the data for our problem statement so that we can make our machine learn. In step number 3, we split our data in training data and testing data. So in this lecture, we looked at the first 3 steps of how to make a machine learn. In the next lecture, I will look at the remaining steps, and then we will start with our practical software installation and also start performing a few practicals so that we can understand using a live problem statement on how to make our machine learn. Okay guys, I hope this lecture was clear. I'll see you guys in the next lecture. Thank you.